Okay, so I hope people, for everyone who was able to successfully, run the Docker, get to the Jupyter Lab, and then connect to the SQL server and to the SQL database. I hope you enjoyed these problem sets. I completely understand that you may not have finished them, or you may have found them challenging. But really, it was just, I think, to highlight that comment I made during the slides, which was that, constructing these queries by hand can be quite labor intensive. Even if the result is cool and the return of the result is very fast, it can still be pretty labor intensive. So we'll go through these answers real quick. Okay, so the first question was to select 10 movies from the table. Okay, so here we've selected 10 movies. In this case, the first 10 movies. And then the second question was to select 10 directors from the IMDb directors in order by first name. Okay, so this could have been done in like a variety of ways. This is just the way that I answered that question. The next question was using SQL. How many? Yeah, please.
I wasn't able to figure out how to do the order after. Like if I wanted
Sure.
the top 10 and then to order it.
Yeah, that's a great point. So there, we're gonna have to
Do they have to go in like a certain order?
So you would want to. So in that case, you want to first. Essentially, what you're doing is you're saying, "Hey, I'd like a table that just has 10 rows selected from IMDb director, right?" And then you would like to order that table, that kind of subtable, by first name. So there, you would have to do something like this, and this is going to complain about not having an alias, which is fine. Okay. So that's what this would look like. Okay, so basically in that case, instead of doing the order by first and then just selecting the top 10, this one you're saying, hey, I want to select 10 rows at random from IMDb director, and then I want to order those 10 rows I've selected by first name, which basically means that you've made like an intermediary table. Did that answer your question? Does that make sense? Okay. And again, this experience was not because SQL is going to this is just showing that there's a lot of power in SQL, but there's a lot of weird syntax in SQL too. Okay, so here we're just counting how many rows there are in each of these tables. Here we're performing a query to ask how many movies in the IMDb movies table came after the year 2000. Okay, here we're asking how many different movie genres are there. So you could either run this command, select distinct values for column genre from table IMDb movie genres. Who can tell me something that's technically missing from this command in terms of what the question was asking? A count statement, yeah. Okay, so of course, in this particular case, I could add that, but also there were enough genres that I could actually literally just count the rows that came out of the distinct statement, but I should have put a count around that. So now we get to the joining tables together. So those in the audience who had the pleasure, I think I saw, we had inner joins, we had full outer joins, we had semi-joins. I saw, there's just every kind of table join statement you can think of, I think I saw out there in the answers. So it's, They each serve a slightly different purpose. Some are like joining two tables and throwing out rows where you don't have matching column values. Some will join everywhere there is something that you can join and keep the rows even if they're not a matching, so there's just joins for days. So here I've just done inner joins. You could have done outer joins or different types of joins. Okay. All right. So this is going to give me this. Okay. So I've joined these two tables together. Here I'm joining three tables together. Your question? Yep.
Is it so? Yeah. In this three table join, there you have multiple instances of movie ID and director ID. Is that okay? Is that bad? Should you do anything to not have?
Yeah, this is a great question. And actually, one of the folks was just running into this. Okay, let's say I wanted to do something. Oops, sorry. Actually spell it right. What do you notice about what I just did? It's in the error message and also in your question. Because there's multiple columns called director ID, as SQL has correctly pointed out. Because again, do not rage at the programming language. It is never wrong. The answer, even though you know what you meant by this query, you know what you wanted. SQL is not wrong. Director ID is ambiguous. There are three columns called director ID. Which one am I supposed to group over? Okay, so it isn't. So the answer to your question is it can become problematic if you want to do an aggregation step over a column that ends up showing up 3 times. That would be a problem. So how would we get around that? One second. Select movies. Group by ID. Do I do directors? Oh, well, it's not liking that. Okay, I don't know why it's not liking that. Let me just quickly. So the point here was to demonstrate that when you're doing your select statement, of all the tables you've joined, you should just pick one of them for the one that you are saving the director ID column of. And yet SQL, so this is where I take back everything I said, because it's complaining about how this is ambiguous, even though it's absolutely not ambiguous. So the only thing I can think is that I need to alias this, potentially.
Well, why doesn't it remove the columns that you join on?
Okay, so it seems like I needed to slap this thing in another select statement. So this would be then like this. And this is complaining about how this isn't in the group by statement, so I would add it. Okay. So anyways, well, I don't want to get too bogged down in that. But the point is you do need to be careful about which columns you select. Okay, so now we're going to do some group by and aggregate statements. So here it says in which year were the most movies made according to IMDb. Okay. So basically, here it's 2002. And one additional thing I could have added in here is essentially to ask just for the first row. Because the answer to the question is 2002, which I've gotten by having the entire group by printed out, but I could have just asked for the first row. Okay. So how many action movies? Okay. So there were 10,135 action movies made after the year 1980. And there were 4,090 made before 1980. Okay? And now the most important question, which is just how many films have been made by Martin Scorsese, which I think Adam was the most excited about having added as a question to all of our statements. Okay. Wait a second. Count. Forgot to count these. Okay, 38. Yes?
If you wanted to order the ones that you had it in a list of like all the counts of different, by the different categories, if you wanted to order it by the like highest number, would you need like parentheses around?
So here, if you wanted to order this table that I just got by the count, by genre, sure. So at this point, yes, you would just slap, actually you could probably even do, give me 1 second, you could probably slap a order by count on here, and then descending. Yeah.
So whether my count was right or not. So
Okay.
what I did was I looked through the table for Scorsese and I
Sure.
then I went into the other Excel sheet and looked through how many so it goes from like 857 to 896, which is 39 instead of 38. I was also getting 38 as the count in the when I was doing the SQL stuff.
Mm-hmm.
We're missing one, I guess.
So, okay, so you got did you mean like doing the Google Sheets route, you got 39?
Yes.
I'd be a little bit more skeptical of the Google Sheets route, but I will double check. I will double check that it's not 39, and it is in fact 38. Any other questions?
Because it's indexing the first count as 0 or maybe something like that.
Could be.
Yeah.
It could be something to do with the index for sure.
Cool.
Usually when it's off by 1, it has to do with indexing by 0 or by 1. All right, and then the rest of the answers are here. I don't have to bore everybody. Okay, so before we go into MongoDB, how do people feel like this exercise went? Pretty okay? Yeah, I got some thumbs up, some nodding of heads. Okay, just keep in mind, you did a lot in this exercise. You ran a Docker, not just one, you ran 3 Docker containers. You accessed the notebook inside of that Docker container, and then you performed SQL queries from that notebook. Right? So I think, you can applaud yourself for doing such a thing. Not a lot of people have, done something that sophisticated before. The one last thing I want to say before we get into MongoDB is, what if we did this with Django? Okay? And so I just want to show you what some of the syntax would be for that real quick. So basically, what you would do with Mongo, or sorry, with oh my God, Django, Mongo, that's too many things. What you do with Django is, again, you would have a class, let's say called IMDb directors, and each, essentially each initialization of the class is a row in your table, right? So here, I'm going to populate the table IMDb directors by creating a list of IMDb director class initializations where the attribute director ID is set to director ID, the attribute first name is set to first name, last name to last name, etc. So you could run this yourself inside the container. What I will say is that running this cell, this cell, this cell, and this cell, which involves you populating the database through the notebook, will take a while to run. So I've already done it for you. Okay? So I just want to mention that this is what it looks like to do all the same queries we just did, but with Django. So here, I'm selecting 10 movies from the IMDb movies table. Here, I am ordering by first name and then selecting the first 10 rows of the IMDb directors table. Here, I'm counting all of the rows in the IMDb movies table. Here, I'm counting all of the rows in the IMDb directors table. Okay. Here, I'm asking for all of the rows in the IMDb movies table that have a year greater than 2000, and how many there are. Okay. So here, I'm asking for how many different movie genres there are. There are 21 different movie genres. So the first one prints out all the unique movie genres, and then the second value prints out the total. So as you can see here, this is much more like what you would expect doing Python object-oriented programming. You have a class. That class has a bunch of different methods. You invoke those methods to perform the exact same queries you were performing in the other notebook when you had to write all those SQL queries by hand. But you are doing so in a much more Pythonically logical way, and then Django is translating something like IMDb movies genre, get the distinct values of the genre column, and tell me all the values of that. It is translating this Python statement into the same, essentially, SQL statement as, which one was the genre one? As this. So instead of having to write this or figuring out how to write this, you can just write something like this. Okay? Okay, and this there's not an explicit way to join tables in Django, and that's actually great, because what Django does is when you need to access a column from a different table, it is performing the joins on the back end that are needed for you. You don't have to write, join movies genre with movies director with directors, genre or whatever. It does all that for you. So I just wanted to show you a few of those answers. I'll send them out. But we can move on to Mongo next. All right, so let me open up those slides. Okay. Okay. All right. So who would like to hazard a guess as to why somebody decided to make a whole database system and database management systems called NoSQL? It seems very personal almost.
Someone is an SQL hater.
Someone say someone hates SQL?
Yes.
You're not wrong. You're not definitely not wrong about that. Any other thoughts? Yeah, Kaylee?
Does it not convert to SQL code on the back end?
So you're getting at the point. You're getting at the point of why someone made a whole thing called NoSQL. Marcus, you want to take a shot? Yes. So another way to describe pitfalls is, boy, isn't creating relations between tables and doing all that work like overkill in certain situations? Does every data set have this intricate tabular relation to one another? Like think about when you create a dictionary. Just a bunch of key value pairs. Just key value pairs for days. Like you could have a dictionary with like 100,000 keys, and each key has like, I don't know, like 3 values associated with it. Does that make sense to like dump into an SQL table? Not really, because it's not like those keys have relations to one another or whatever, but you want to store that giant dictionary somewhere. NoSQL. NoSQL is really for your data sets that are just these like, basically if you imagine your data is just like a giant dictionary and you need to like have like a place to store just like a bunch of, like a huge amount of dictionaries, like then MongoDB is for you. What's the other thing that inherently seems a little tricky with SQL? In terms of kind of getting, it's another pitfall, like our supposed pitfall. Okay, it might seem like, what if you all of a sudden decide like, oh, I have a brand new attribute. I have a brand new column. And you already have like an existing very delicately crafted like tabular relationships. It might seem a little daunting to like add new stuff, new columns into that whole setup. Mongo says, oh, you got a new key in your dictionary? I don't care, just insert it in there. Like, oh, you had 100 keys before, now you have 200 keys? Cool, I can handle that kind of like arbitrary growing and shrinking of like your data. Okay? All right, so we cover the pros and cons here of the traditional SQL system. So SQL systems, database management systems, have been around for a long time, as we've, I think, covered, and hopefully people do appreciate. It's very powerful to do. The ACID compliance, this is the thing that basically means that when we were talking about non-corrupted things, if you're trying to do multiple writes, the database won't become corrupted. The schema, it's a good way to group tables together, et cetera, et cetera. It's a reminder of ACID. It's consistent, so there's no violation. It's isolated, so if you're doing a transaction on one table, it's not affecting the transaction being done on another table. And durable, which means like if you make a change to a table, it won't all of a sudden revert. Okay? So the cons of the SQL system, this is kind of what I was talking about with horizontal scale out. Okay? Who can tell me what horizontal scale out is? Not vertical, I like that.
As you join tables, you end up with all these different columns. Bigger.
Exactly. It's more of a column, not rows. We've talked about SQL loves trillions of rows. Doesn't love trillions of columns. That is not what it wants. Okay, so what is, and that's why I mentioned the dictionary. The dictionary with 200 keys. From a database perspective, what are those keys? They are columns. Exactly. So not in love, like SQL, not in love with horizontal scale out. Okay? And as you probably noticed, okay, I mean, we were already pushing 3 inner joins. Let's say you're pushing 100 inner joins across 100 tables. Then you're getting into the same horizontal scale out problem as was just commented on, by just joining too many things together. Okay? Okay, the object relational, I don't know if I agree with this, so I'm going to disagree with this as a con. All right? So, because to me, they're basically saying like, hey, relational databases isn't very like object-oriented-y. And I think as we showed with Django, that doesn't have to be the case. You can write an object-orientedness on top of it if you want to. Okay, so basically, people were like, hey, what if I have big and like really unstructured data over time? So like today I have a dictionary with 100 keys. Tomorrow it's going to be 200 keys. Like a year from now it's got 1,000 columns all of a sudden. Why? Who can think about like why that might happen?
What if it's like students that are enrolling and unenrolling?
Sure, you have something like that, and let's think about. I like the students idea. Think about the metadata you have about a student today versus 10 years ago. How many attributes went into describing a student 10 years ago versus how many attributes you could think about that describes a single student today? Very different. How would SQL handle that? Well, you'd have to be prepared from 10 years ago to have a very different table today, which might be a real pain in the butt to do. Mongo says, if in 10 years from now you're going to have 500 attributes instead of 100 attributes to describe your data, no problem. We can kind of just arbitrarily expand and collapse as you need. And again, that's that horizontal scaling. Okay? All right. Now this comes at a cost. Let me just read these costs real quick. I want to decide if there's any I don't agree with in terms of costs. You might think like, aren't these your slides? Why would you disagree or agree with them? You gotta keep in mind these slides are from 2 years ago, and things evolve rapidly over that time. Most systems lack that kind of ACID transaction. That's fine. Some systems exhibit potential loss rights to the database and other forms of data loss, but not MongoDB. To me, pretty much the name of the game in research that you would be interfacing with is MongoDB. So this caveat that there are other non-MongoDB NoSQL systems that may exhibit data loss problems seems a little not necessary, because this is the only game in town pretty much that you'd be dealing with. No schema means data integrity might become an issue. Some systems do allow defining schemas, many query language. Yeah, okay. So this is basically to say the same thing as with many things, which is like NoSQL, it's kind of new. It means there's a lot of competitors, a lot of people trying to be the main NoSQL database management system. But at this point, as far as like I've interfaced with, MongoDB won that competition. So some of these cons aren't as worried about. So again, NoSQL means not, you might wonder, like, what if I still have some relational data? Can my NoSQL database handle it? There is ways for your NoSQL database to handle relations between many different NoSQL tables. But there's a lot of caveats that go into making sure that's performant. Go ahead, Brian.
Can you say more about that con on the previous slide about data loss? I mean, yeah, shouldn't a database have one and only one job? To not lose data?
It's a good question. I just want to think about how to phrase this. In my experience, what I think this is referencing is when you don't have something like, I have column A, it can take in values between, X and Y. When you don't have something that's that rigorous, and you've basically are like, nah, wild, wild west out there. You insert whatever, what did I refer to them as? Sort of like documents into this database that you want. That can lead to, when you don't have that kind of constraint or integrity, like overarching rule, you are opening yourself up to inserting things that cause trouble into your database. So that's what I think. That's why, again, how was it phrased here? I think. Which is, what was it phrased? Yes, always comes with a cost. That level of flexibility sounds great in practice, but is not great, cannot be perfect. Like if you're going to allow arbitrary, essentially row insertion, for lack of a better word, you are going to be potentially dealing with some integrity issues. Okay. Yes.
I'm so sorry, this question had been bothering me for a while. But are you related to Matthew Coughlin that's in the beginning of your slides?
That's a totally valid question. Yes, Michael Coughlin is my brother.
Aw.
Yes, so I'm sure many of you have interacted with Michael at some point. He is faculty at the University of Minnesota now. And yes, he is my brother. So.
Thank you.
Yeah, absolutely. Absolutely. I don't know if I needed to be thanked to be his brother, but I mean, I'm happy to acknowledge it. So yes. Now, Michael actually, we both share a love of databases. I will say this: Michael and I share a love of databases, and he honestly deals with. I'll be totally transparent here. I have dealt far more with SQL, Django, and stuff like that. NoSQL is still quite new to myself, to be perfectly honest, just to be transparent. But it's important to be aware of, because you are going to hear people who use MongoDB, specifically MongoDB. I would be shocked if somebody came and said, I actually use this flavor of NoSQL. That would be shocking to me, but MongoDB specifically. Okay, so what are the different flavors of NoSQL? Okay, so there's the key value store. Okay, so it uses maps, dictionaries, associated lists. So again, I think the best way for me, instead of worrying too much about the parlance of document store and things like that, I really just think about you have arbitrary Python. Imagine just having arbitrary Python dictionaries and needing to constantly insert them into a database. That's what NoSQL is, kind of designed at its core. Okay. Okay. So all of these different, my God. All of these different data store models have different trade-offs in terms of performance, scalability, flexibility, complexity, and functionality. Okay? So basically, again, let me just summarize what NoSQL is. Somebody came along and thought, what is every single situation with SQL is not appropriate for my data, and let me make some vague, let me make some like offshoot of NoSQL designed to handle that data type. The data type that I would really care about is this first one, the key value store. Don't worry about the other data model types. I really doubt that they're going to come into play here. Really just think about the key value. Okay? So the key word here, somebody, not even low. Not even low. Complexity, none. So going back to Brian's earlier question, what do you if you showed a graph to somebody and you said, hey, oh, sorry, my Google Watch or my Apple Watch is trying to listen to me. You said, hey, I have this new solution, it has complexity none. What would be your alarm bells should be ringing in terms of things like, what about like data integrity? Like are you sure this is like foolproof? It has no complexity and it's going to just never be a problem. Alarm bells should always ring. But it's not untrue. The complexity is none for key value stores. Literally just think about a dictionary and imagine just constantly, like every dictionary you had was a new row in a database. And arbitrarily, you can just keep entering it into a database. Okay? All right. Okay, so again, uses BSON because we have to have a new word for everything. This is a binary formatted Python dictionary-like structure. Okay. Okay. All of these Python dictionary-like structures are stored into things that are called collections, i.e. tables. Why are they called collections, not tables? Because this is NoSQL. We can't use words that sound anything like SQL. So think of a collection as really just a table. Okay? And again, we have the Mongo query language, not to be confused with the structured query language of SQL. We have a Mongo query language. Okay? So let's do what's really just important here, which is let's compare the SQL query to the Mongo query, because most people are going to be familiar with the above, and most people will have never seen the query below. So I have a collection called people, and I would like to insert one quote-unquote row into the quote-unquote collection called people. What do you notice about this statement here? What's the first thing? I've used what's that? It's a dictionary. So to insert a row into not a table, a collection called people, you literally just make a dictionary. The key, user ID, key age, and key status are essentially your columns. And then the values that go in are the rows take the values of ABC 1 through 3, 55, and A. So you can see, in terms of the complexity of making and inserting a brand new row into a MongoDB database versus creating a table and inserting rows into an SQL table, which one of these would you describe as more or less complicated? For most people, it would be this, because they're already used to making dictionaries, and now you just insert dictionaries arbitrarily into a database. Whereas this, again, this has all of these gnarly things, like you can't just create a column called name. The column name has to have a type associated with it, right? In this case, a character that cannot be any more than 20 characters, a string that cannot be any more than 20 characters long. You have RA, which has to be a float. And if I was doing this correctly, I should have added an additional thing to RA, which is can only take values between, whatever, -90 and 90 or 0 and 360, whichever one it is. And same with DEC, right? This is a lot simpler for people. There was no typecasting. There was no anything. You just made a dictionary and inserted it into a database. Okay, what if I wanted to alter a table? So here I'm saying, hey, I'd like to take the table star. I'm going to add a new column to it. And I'm going to put that new column after the column VMAG. Or here I want to say I'm going to alter the table star. I'd like to drop, I don't want this column anymore, the BMAG column. Okay? This is how you would add a new key to your people's collection or database. Okay? So this is where you have to ask yourself, is this or this more complicated? I leave that up to your own discretion. Okay? Dropping a table, similarly easy. This, I've deleted the table star. This, I've deleted the collection people. Okay? Here I'm going to insert certain values into my table. Again, I would say creating a dictionary and inserting it is easier than inserting a new row in a table in SQL. Here I would like to perform a query where I find all rows from table star where the DEC is greater than 0 and order by VMAG. Here are some of the equivalent select statements in Mongo. It's called .find. So here I am basically performing my query with a dictionary. Okay? So here I would say, let's take a look at this one. Here I would like to find all quote unquote rows in the people MongoDB collection where the column, the quote unquote column status is equal to the value A. And user ID is 1, status is 1. Okay, so this is how you perform like a where statement in Mongo. Yes.
Do all the rows in the selection need to have the same key?
It doesn't matter. So you should be able to, so here where I did this, insert 1 user ID, we'll test this later in the notebook. You should be able to insert a new dictionary that only has like age and status in it. Or has age, status, and, do I like this person or something like that, in it. Okay? So again, I just wanted to translate. There's a nice little screenshot here. This is probably the most important screenshot. That's just basically translating where to the match statement, group by to group, select to this project, order by to sort. It just does the mapping from the SQL-like function or concept to the MongoDB concept. Okay, so we have these slides, including these things, but I think what will be most effective is to just try it out in practice, and that's what we're doing in the next notebook. So before we do the next notebook, I want to make sure we have a break till 4, so like a 15-minute break here till we kind of gun it to the end. Are there any questions here? The most important thing to think about is, can you conceptually see why somebody went through the trouble of creating an entirely new database system for this type of problem or this type of data? Right, because these arbitrary dictionary inserts is not really appropriate for SQL, especially depending on just how many keys or columns you have per insert, per document. Yeah? Could you repeat the question? Sorry.
I'll try this. So basically for scientific applications, do you usually see SQL or NoSQL databases being used?
Yeah, for specific applications, that's a great question. So the number one place I see Mongo, so DB deployed, NoSQL. So a lot of folks, maybe they have huge workflows they need to run. And they need to run these workflows not on a single system, but on systems like the Quest compute cluster. They need to go to the San Diego compute cluster. They just have like so many simulations they need to run for a single project, but each of those simulations needs to be tracked. You need to like track, like, is this running? Where is it running? Has it finished? And stuff like that. And there are workflow engines designed to handle that, and they are back-ended by MongoDB. Because basically, when you're trying to do something at that, like essentially high throughput computing, there's not really a relationship between all of these jobs, right? Like all these simulations that need to run. You just need to have it documented somewhere in a central location that all of these different places can access at the same time. You just need to have it documented that, hey, 500 runs are being done on this computer, 700 runs are being done on that computer. What's the current status? Oh, 300 of them are done. Cool. Like there's sort of, you need to have a central source of truth, but there's nothing relational about the data. There's nothing like, they're just sort of independently being tracked things. Does that situation make sense? And then SQL, of course, like you would never do something like that for telescope data, as was shown in many of the slides, right? Because you're going to have a table that has just the sky location. Then you're going to have a table that has all the magnitudes over time, right? You're going to have all of this data that is relational to each other from like any telescope or any optical data, really. So those are two situations that come to mind. Okay, so let's take that break. Maybe 4:05. It's 3:50 now. Let's come back at 4:05. We're going to set up we're going to turn off. We're going to shut down the old Docker. We're going to go over to a new Docker and spin up PyMongo and MongoDB now. All right. Don't worry about the count question. PyMongo got rid of .count. And it got rid of .count in a very new version of PyMongo, much to my chagrin, trying to run this notebook. So in case you're curious, and it makes no sense, but the new language is estimated document count and then count documents. So it's not count, it's count documents is how you perform the count operation. Why they had to get rid of .count, which of course is intuitive and makes sense to like anybody who would be coding, I don't know. But this is something. What's that? Same as SQL. That's right. You're good. Thank you. That's the right ad. You're right. They thought it was too similar to SQL. They got rid of it. You know, that is probably what happened. Right, so this, basically I have in this first cell, I have made all of the quote unquote tables. They're called collections, but I've made all the collections already. And so the collections that you will be operating on are quite literally collections 1, 2, and 3, which are part of, what did I call it? Yeah, database. Okay, so you can see that all the collections, so the database in this is called DB. The collections are DB dot, whatever that name was that I gave. up here. So db.imdb movies, db.imdb directors, db.imdb movie directors, and so on and so forth. All right, and then, all right, so I know we had Marcus make this comment already. I hope people are experiencing this. Syntax feels a little clunky. Feels a little clunky building out those essentially chained dot blah, blah, blah statements. So there's no doubt about that. In my opinion, I agree. You know, for all the benefits that NoSQL or Mongo gives you from maybe the perspective of making that database and making the collections in that database was super simple, way simpler than SQL. Interacting with the tables in the database once you've made them, not as fun, not as easy as SQL. Okay, so spinning up a MongoDB database and jumping things in it, yeah, like you're way easier than SQL. Interacting with it after it's been made, I still like the sleekness of SQL. And I think that was, as you may have noticed in one of the slides, denoted as one of the cons. That something like the structured query language SQL has been developed over a long time. It's used by many people, whereas the syntax for interacting with the MongoDB is literally custom to MongoDB, right? Like it's very localized. It hasn't been matured as much, which is why they do things like all of a sudden drop count and change it to a different attribute or a function call.
Yeah, can you show that again?
Yeah, absolutely.
I can't even read the docs because the docs are not updated.
Yeah. No, I hear you. Now, did I link to which docs did I link to in here? No, I linked to the docs. Yeah. So they are. Oh, Mongo's website's down? Yeah. Oh. It's probably not great for. Sorry, it was these ones that we wanted here. Yeah, no, for sure. So Marcus brought up this point, which I think is important to note about Docker. So one thing I wanted to note for those who are wondering, like, hey, where does my Mongo database like actually live in this whole Docker container environment? You might notice that when you spun up your Docker containers, there's something in your Docker desktop called volumes. And we've been talking a lot about how Docker can mount your local file system so that when you make changes to a file on your own computer, that they're persistent, right? That they last after the Docker container comes down. Docker actually has a way to make the inverse true. So that when you make changes to a particular file system that's only in the container and you shut the container down, it will survive past the lifetime of the container. So the same thing is true for Mongo. So if you're in a similar situation to Marcus and you've run that cell number 2 multiple times, which means you've inserted the database or the table essentially multiple times into the same database, to truly clean everything out, what you would need to do is in that directory that we've been running the Docker compose up and Docker compose down steps, you would run docker compose down -v. Okay? And you'll notice a very important thing, that it says that it's done over and above when you just say down. It's removing the persistent volume or storage associated with the Mongo container. What's in the persistent storage associated with the Mongo container? all of those Mongo databases you just made from Jupyter. So at this point, I have totally wiped everything to do with Mongo and the Mongo databases. And so if I go ahead and spin them back up with the up command, these volumes will be back. Okay? But, and unfortunately I should have taken a snapshot of this, you would notice that the size of this volume is much lower than it was when there were actually databases in this storage, this persistent storage that Docker has. So this is how you can kind of totally wipe everything perfectly clean, then bring back up both the Jupyter and the Mongo and start fresh. So let's say you made one little mistake and you wanted to make a tweak. So like in this particular case, you've sort of remade your Mongo collections or your Mongo tables twice. There are certainly commands you could directly run from like PyMongo that say, hey, actually, can you just drop this one table and I'm going to remake this table? We saw those in the slides. I think it was in SQL you would say like drop table star, and in Mongo it would be like database.drop name of the collection, and then you would just totally wipe the collection out and you could just remake it again without having to go through this full-on wiping from the Docker side. So you could do it programmatically, but sometimes I would say there are situations in which programmatically clearing the decks is more work than just having like Docker clear the decks fully for you and starting from the beginning. So it depends on which way you want to go. So you could undo those changes from PyMongo, or you could have Docker just totally wipe the deck and start clean for you. Depends on which way you want to go. So let's go through the answers here. So before we go through answers, I think again, this is mostly, it's not about filling out all these problem sets. It's about getting familiar with the sort of thought processes that go into both the NoSQL and the SQL stuff, right? And hopefully people have felt like they at least have been put in that mindset when trying to solve these problems. And I hope people enjoyed being exposed to SQL queries and being exposed to NoSQL today. You know, I want to continually improve these notebooks and improve this material, so please do give feedback on how you felt like things went. You know, like I said, this is really my first time giving this. 2 years ago, I technically gave it. But we can only say that I technically gave it. We can't really say that I gave it. So here, again, I just wanted to provide one just sort of like syntactical thing. This is how you would search the IMDb directors collection to find every, like what do they call a document? Every document with the last name, the key for last name set to Scorsese. So here we're going to select 10 movies. Okay. So we use that .find statement, and then we say we're going to limit it to 10. Okay. Here we're going to again we're going to use that .find syntax. So we're going to sort by first name, and then we're going to limit to 10. In this particular case, because this was asked last time, I don't see any reason in the PyMongo-iness. So remember in SQL, if you wanted to limit 10 and then sort, that was a whole chore to do that. I think in the way that the things daisy chain together, that you should be able to basically just swap these together to first get 10 documents and then sort them by first name. Okay, so again, you know, even though people might have found the PyMongo syntax a little clunky, and if you did, that's really okay, it still has some of those nice Python intuitive aspects to it, which is like, oh, I just want to switch the operations of things. I just switch around the dot limit statement and the dot sort statement, whereas in SQL, swapping around the order by and the limit by was more of an involved thing. Okay. Here again, they got rid of the dot count, which again is just dumb. I don't know why they did, but they did. Okay. Here we're going to count how many movies there are after the year 2000. Okay. Here we're going to get all of the unique genres. All right. Again, I should probably put like a dot count statement after this. Or actually, you can't do a dot count statement. So whatever the new dot count statement would be in PyMongo. Okay. Here we're going to get the information on in which year were the most movies made according to IMDb. You can see here that it's the year 2002, which is the same year as was, from the SQL query. All right. Here we're going to ask how many action movies there were after the year 1980. Okay. Unlike in SQL, where I was a little bit more easily able to like sort alphabetically the genre, you can see here that we have 10,135. And then if I ask for less than, it should be 4,090, just like it was in the SQL case. Okay. And then let me again just enter this. Okay, so here again we're running the count documents. So we're saying select all films that were made by Martin Scorsese. Okay. And the value is 38, just like it was last time, except for we did have that one contention that maybe it's actually 39. But for now, this is consistent between Mongo and SQL. Okay. And then this one, which director has directed the most movies? It's our friend Flesher. Oh, did this actually answer your question about how to include the last name in there? Yes. I think it did. So this is how you can include the last name of the director, even though that's not what you're aggregating on necessarily. So that was 615 movies directed by Flesher. And then last but not least, according to IMDb data, which director has directed the most movies in each genre? Okay, and the answer is Flesher has directed apparently 611 animations and 604 shorts, which would also explain why Flesher was the person who directed the most movies, period. Melanie.
What is the underscore ID doing?
Yeah, so the underscore ID is essentially playing the role here of column identifier, because again, like NoSQL doesn't have any sense of columns. It's sort of like it has key value pairs, but you're essentially saying, hey, return to me the keys, last name, genre, and director. And last name, genre, and director are going to be assigned the $sign there. You can see I'm basically reconstructing my own dictionary. I'm like, I want to be returned a dictionary with key value last name, and then the actual name of the director, key value genre, the actual genre from the database, and then key value director ID. And you can't see it, but there'd actually be the director ID. So I'm basically saying, return to me a table or a dictionary formatted in this way. It's similar to when you do the select from statement where you're selecting which columns you want formatted in the way you want. This ID is essentially saying, this is how I would like this query returned to me in as human readable as a form as dictionaries can be.
Why is the genre listed multiple times? Genre?
Yes, so that is definitely true. So what I would want to do is add a statement in the group by that says take the first element or the first entry for each grouping of genre and director, which I didn't do. So you're right. Actually, I would say this answer is not quite correct. So I will fix that before I send out the answers. Good catch. Good catch. All right. So I will fix the answer to 4D because I agree. I don't think that's quite correct the way I did that. Yeah.
Only if this is an easy question. I was also trying to play around with it, and I couldn't figure out how to do like you would in SQL, get strings like something with one.
Yeah, the like statement. That's a good question. I don't know off the top of my head how to do the equivalent of a like statement in SQL here. But like for instance, if you wanted like all last names that started with F, something like that, I'm not sure how to do that in PyMongo. That's a good question though. Okay. All right. So I'll send out the answers to the SQL notebook and to the MongoDB notebook. I will fix this last answer because I agree it's not complete. And then with that, I hope everyone has a good rest of their time here. Yeah, just a quick reminder since I was asked, do run the Docker Compose down to shut down all of your containers. So in the same terminal where you ran Docker Compose up, go ahead and run Docker Compose down.